Now coming to the question of Amazon, which is leaders in an array. Which is the element that you call a leader? An element in an array is called a leader if there is no element greater than it on the whole right side. On the whole right side of the array. Okay, let's have the definition. A particular element in an array is called a leader if no element greater than it exists after it. Exist after it means there is no element greater than it on the whole right side of the array. Let's take a very simple example. If I talk about 16, what are the values on the right of 16? Values on the right of 16 are 17, 4, 3, 5, 2. Now, if you see in these values, any value greater than 16 exists? Yes, it exists. So 16 will be a leader? No, 16 will not be a leader. Okay. If I take about 17, 4, 3, 5, 2. No value is greater than 17. Then yes, 17 is a leader. Similarly, if I talk about 4, values are 3, 5, 2. In that case, there is a value which is greater. So it is not a leader. Output no. If I talk about 3, only 5, 2. No value. Okay, there is a value. So again, it is no. And in the case of 5, you have 2, no value greater than the right. Output is yes. In case of 2, there is nothing. So obviously, it's going to be yes. This is your question. You're given an array. You need to find which are the leaders in the array. So coming to answer of this question, 17, 5, 2, 2, 5, 17, whatever order you want to give, that will be the leaders in the array. Okay. Order you can give anything, 2, 5, 17, 5 to 17, whatever. I just want to find what are the leaders in the array. Again, I'm repeating, leader is an element such that no element greater than it exists after it, or no element greater than it exists on the whole right side of the array. Its variation can be asked, whole left side, and other variation can also be asked. Leaders, it can be changed like no smaller value on the right, no smaller value on the left, no greater value on the right, no greater value on the left. Once you're done with one kind of question, you're done with all kind of questions. So 4 questions can be derived from it. But let's have a look at this question. Let me know if the question is clear. Any doubt in the question, feel free to ask. Let me know if the question is clear. Any doubt in the question, feel free to just type clear in the chat if question is clear. Okay. Those people who are new to you, the way we follow problem solving here, or the way we solve actually problems here, is that I explain you the question, I give you the company, I give you the sample input, sample output, understanding of the question. The moment you are clear with the question, then I give 30 seconds. In that 30 seconds, I expect code, time complexity, space complexity. This is the way we follow, the new people I'm talking about. Okay. The previous one, you already know the flow. Okay. 30 seconds on the clock. I want everybody's code, time and space complexity. You want to write the approach, that is fine, but prefer writing the code, that will be helpful. If you just want to write the approach, that's fine. And slowly you'll be reducing the time from 30 seconds to 25 and so on and so forth. Okay. Cool, guys. Enough time. Let's discuss the answer. Then we'll discuss the complexity as well. Return 0 is leader I plus 1. Recursive code. Okay. Return false, return true. Let's see. Let's see all the solutions. Let's see the approach. I think brute force one, all of you have already figured out. So I will just keep it very quick. If max greater than, that's also brute force. Count plus plus. Why do you need a count? You just need to check whether it's area, whether it's leader or not leader, right? Whatever it's leader, you mark it as true, false. Whatever boolean you can keep and you can return the answer. That's also fine. Or you can keep a vector, you can return that. Accordingly, as per the question, we can decide. But counting how many values are greater than it's not required, right? Okay. Anyhow, let's discuss the solutions, which I think brute force all of you have come up with optimizes that we'll spend more time on. Brute force solution, this question can be simply solved by 2 nested loops. Why 2 nested loops? Understand the question. there is no element greater than it on the whole right side. Now, when you say whole right side, for one particular element, I need to travel the complete right side. All agree? When you say whole right side, you will take I for the one part and the complete j will travel from I plus 1 to n. Now, when you're saying j will travel from I plus 1 to n, when you say such kind of a statement that for every value, I'll be traveling all elements on right or all elements on left, this is itself a big of n square approach. This is itself a big of n square approach. This is itself a nested loop. Why? Because first thing is that you're traveling for all values on the right. That is the j part, inner part. And you're traveling for all values. That is the outer part. So I will be a loop. For I, you're traveling all j's. So for I, you're traveling all j. That is nested loop. That is big of n square. Now let's have a look at it. What you're saying is for I equal to 0, I less than n, I plus plus for all values. What I need to do is I need to travel for all values on the right. And this part, I think all of you know and should know if you don't know. Whenever you write j equal to 0, j less than I, j plus plus. This is left of I or right of I? This is left of I or right of I? See the code again, guys. I is the current index. You're traveling from 0 till I minus 1. This is 0 till I minus 1, right? When you say I equal to 0, I less than n, the code is running from 0 till n minus 1. So this part is left of I. If I have to travel to right of I need to do I plus 1, then j less than n, and then j plus plus. This is something that we need to do. This is what you call values on right. So for each element, you're traveling on values on right. After traveling for values on right, all you need to check is if your array of I is less than array of j. Array of I less than array of j. It means there is a value which is greater than it on the right side. No, nothing to do j minus minus. There is a value which is greater than it on the right side. Leader or not a leader? Leader or not a leader? Not a leader. What should I do here? At this very moment, what should I do here? Flag equal to false or break. Returning return true, false, that you can do for each value. That's also fine. What I'm saying is the moment you recognize it is actually not a leader, there is no point of traveling forward. Understand this. This code will run up to n times. N can be 1 million. Let's say array of size 1 million. At second index, you understood this is not a leader. Why are you traveling 1 million? I agree. What I'm saying is, let's say 16. At 17, you get to know 16 is not a leader. Is there any point in traveling 4, 3, 5, 2? There is no point. Once it is not a leader, it will never be a leader. Once it is not a leader, it will never be a leader. So the moment you have recognized it's not a leader, there is no point in wasting iterations. There's no point in wasting time there. So immediately break from there that this is not a leader. I have broken from there. Okay. So this is, there is a value which is greater than array of I on right, hence it is not a leader. Okay, so that's why I put a break here, and let me comment this part to understand. Now coming to this part, if j reaches to n, I hope all of you guys know this. Whenever you write this kind of code, after this loop will complete, after this loop will, first of all, this loop will successfully complete only if the break is not hit. Agree? This loop will successfully complete only if the break is not hit. So this completed and this condition is never hit. After this loop, what will be the value of j? After this loop, what will be the value of j? N minus 1 or n? N minus 1 or n? Basic parts are clear to all. This will be n, not n minus 1. This loop is running till n minus 1. But why the reason it get out of the loop? Because when the j becomes n, that's why it did not satisfy. That's why it got out of the loop. So if j equal to n, in that case, yes, it is a leader. Yes, it's a leader, and then you can print it. cout or print whatever you want to do, array of I. You can print the leaders in that. Time complexity, big of n square, space complexity, big of 1. No extra space being utilized. This is a brute force way which almost all of you have come up with. Coming to the optimized solution, which is expected in the interview. Let's have a look at the optimized solution. The trick or the logic of optimized solution actually lies in understanding the question carefully. See, if I talk about the last element, my last element will always be a leader, irrespective whether it's 2, 3, 5,000, -1, -2, whatever. All agree? Why so? Why so? Because there is no value after the last element. Since there is no value after the last element, obviously this is the only value, so it is always going to be leader. That gave me an intuition that instead of traveling left to right and maintaining for all the values, what if I can travel right to left? Understand the intuition, then go for the approach, then go for the code, then dry run, then complexity. This is the flow that you should build in terms of interview, in terms of general practice as in engineering. Now, if I'm traveling from left to right, I need to keep track of all right elements. That is what leading to the big of n square complexity. If it's greater than leader, then current element is also leader. Okay. That is what's leading to big of n square complexity, because I have to keep track of all values on the right for my current element. But if I think of something where I can travel from the right and I can keep a track of maximum values, I can solve this answer in big of n time. Why? That inner part, where what was the complexity here? The complexity was the inner part where I have to keep track of all right values. If somehow I reduce that, ultimate the other loop is, or ultimate outer loop is big of n. So if I can reduce that inner part, that will give me a very big optimization from big of n square to big of n. Let's understand this, then we'll talk for more. Instead of traveling from right to left, or instead of traveling from left to right, you travel from right to left, right to left. You keep a max, initialize max with rightmost element, which will always be a leader. This rightmost element is going to be always a leader. Okay. Now, what you're doing is traveling from right to left. If you find any value which is greater than your max, you initialize max with that value. You update your max basically, and your max will become the new leader. Okay. Let's have a look at the code. Then we'll try on this to understand it better. I initialize my max with array of n minus 1, which is the last value. So first I'm going to print the last value. Why? Because it is always a leader. Now what? For I equal to n minus 1 or n minus 2? N minus 1 or n minus 2? When you're traveling from right, n minus 1 or n minus 2? When you're traveling from right to left, it should be n minus 1. But I've already checked for n minus 1, so there is no point of doing that. You can do it, it will not cause you anything, but there is no point of doing that. You can simply put n minus 2. Now, if your array of I is greater than max, then your max will become the new max, and this is going to be leader, and this is update max. Yeah, I greater than equal to 0. Okay, this part, and that's all. Time complexity big of n, space complexity big of n. Let's have a dry run what I'm actually doing in this part and how it is working. Okay, so let's take this array and 17.5. Okay, let's have a dry run. What you're doing is, what if all elements are same? Sorry, but how we say array of n minus 1 is leader? Okay. The definition of a leader is there should be no element greater than it on the right side. This is the definition. Okay. No element greater than it on the right side. You will check for all elements. You find nothing greater, you will claim it's a leader. If there is no element at all, obviously it is a leader. It's like saying you are taking elections. The person who gets the maximum votes, he or she is a leader. But if there is only one person, obviously he is a leader. He or she, whatever, right? So if there is no element on the right of 2, by default 2 becomes a leader, or by default the last value becomes a leader. That's why we're creating n minus 1 a leader. What if all elements are same, or we have 2 elements same? If all elements are same, then you cannot claim a leader. Only the last element will be leader. If I make 2, 2, 2, 2, 2, only last 2 will be a leader. That's all. Okay. It's not about greater equal to, it's only about greater. Now let's have a dry run to better understand this. I'm traveling from right to left. Right to left, I'm traveling. I've initialized max equal to 2, rightmost value, and I'm calling this, yes, it is a leader. Next value I have is 5. I'm traveling from right to left. Next value I have 5. Is 5 greater than 2? Yes. So 5 greater than 2, I update my leader. Yes. Max becomes 5 now. Okay. Now I come to 3. A of I is equal to 3. Is 3 greater than 5? 3 greater than 5? No. Should I update it? Should I update the max? Max will not be updated. Leader will not be updated. Move forward. A of I equal to 4. 4 greater than my current max? 4 greater than my current max? No. Leader updated? No, it's not a leader. Move forward. A of I becomes 17. Now, 17 is greater than 5. Now it becomes a leader and my max becomes 17. Next value is A of I equal to 16. Is 16 greater than my current max? 16 is not greater than my current max. My array is completed. Okay. So final output you get those values which are yes, 2, 5, 17, 17, 5, 2, whatever. These are leaders in your array. Have a look at the code, have a look at the diagram, have a look at the approach. Let me know any doubts so far. So this question is clear, no doubt here. Code, dry run, approach, brute force, optimize, all. Okay. Let's move on to the variations of this question. And you guys quickly tell me, how will you solve it? What can be the possible variations? Variations can be leader you are calling when there is no element greater on the right side. So leader definition, no element on, no element greater on the right side. This is the question we have just done. Okay. Possible variation can be leader can be element where there is no greater element on the left side. How will you solve that? How will you solve that? Come on, guys, we just did. If there is no greater element on the right side, I solved it in one way, just changing the loop. This time you will run from right to left or left to right. This time you will run from left to right. As simple as that. Yeah, brute force way is always there. I'm talking about the optimized approach. We'll go from left to right. Similarly, variation can be no greater element. So let's take 2 variations of these questions. Let's make it here. This no element. So I'm just writing approach here. Here we'll travel from left to right, maintain max, maintain whatever max. If the question becomes leader is an array or leader is a particular element such that no element smaller than it on the right side. Now what will you do? Now what will you do? Quickly. Just change the symbol instead of maintaining a max. No. Instead of maintaining a max, no. See, you will be traveling from right to left for sure. That is for case. That does not mean you will start traveling from left to right. Understand the logic. Understand the logic. Why we are traveling right to left? Because I want to cut the inner loop so that my complexity become big of n square to big of n. I will be traveling right to left for sure. But instead of maintaining max, I'll be maintaining min. So let me put it here. This time, this would be right to left. And I will maintain max. This would be left to right, maintain max. Left to right, maintain min. And left to right, maintain min. I think all 4 variations you guys are able to do now. All of you guys can do all 4 variations or any variations coming to this question exist. Okay. I think there are some questions. Let me check. Try out these questions. I'm not sure if they're available on LeetCode or not, but you can make question, you can try it by yourself, solve it in big of and complexity. Given an array, I think this is on LeetCode, but let me check again. Replace every element with a greater element, replace every element with a greater element on the right side. Okay, which means not including the current element. Okay, let's take this question, this array that I have just taken. Let's see this part. This is the array. Output will be what? 16. It will be replaced with 17. 17 minus 1, 4, 5, 3, 5, 2 will be minus 1.